All right, we're going to take some of these formulas for surface area. I'm going to walk you through some of them. They're all here on one page. On the next page, I have our objects. We're finding the surface area, and I've already input the answer to your packet. So this is basically just to make sure you can get what you're supposed to get. So our first picture of our four on this page would be a rectangular prism, uh, known like a box of tissues or cereal box. Here we have our rectangular prism on the previous page, or surface area, 2 times LW plus 2 times LH plus 2 times WH here. Let me copy this onto the next page so we can use it, so we don't have to keep flipping back and forth. Let's do a paste. All right, so here's our formula. It's L, W, and H for length, width, and height. Now, it doesn't matter which one is which. If you think the 9 looks like the height, go ahead and make it a height. So everywhere you see H in the formula, in this spot, we'll just put a 9 there. If I want 7 to be my L, so that I know every time I see an L, I'll put in my 7, and then my 13 can be W, and then everywhere I see a W, I'll just put the 13 in. So we start off with 2 times L times W plus 2 times L times height with another plus sign, 2 times WH. And all that should get you 542. All right. So our next one is a triangular prism. So our triangular prism is in the middle here. Losing my mind. All right, now I can write. So we have a more, not as big as a formula, but certainly a lot of stuff going on here. So your H is pretty easy to find. There's your height. Your P stands for perimeter of the base. And capital B, notice this is a capital B and not a lowercase b, means area of the base. And we need 2 times it. So let's talk about a base. And I think it's easiest to find a base if we look at this picture here, because base is found the same way. So a base, let's say this is a Pringles can. The base, when they started doing these formulas, they used soup cans, and they had to say the base was something that it could actually sit on. So if we were to sit this can on its bottom, you would see this would be the bottom of the can and this would be the top of the can. So we would name those as the bases. So this object, this cylinder, the soup can, has 2 bases. So if you look at this picture, our triangular prism, we would say, well, it looks like our 2 bases are going to be this one that's shaded and this one on the top. So look at the picture on the next one. We usually say a base is something that has 2 of, because we have a top and a bottom. So our base is going to be here. I'll put a capital B for here and a capital B for here. Okay? So it says on our previous problem, it says find the height times the perimeter of the base. Okay? So our height for number 4 is 16. There's our first number. Now let's find the perimeter of the base. Okay, so if this is our base, it has one of three sides, but if you look at the top base, it gives us the other two sides of the base. So the three numbers on this triangle base here would be 15 plus 9 plus 12 to get our perimeter. And I'm going to put that in parentheses as our lowercase p, 15 plus 9 plus 12. Okay, so there is our first part of the surface area formula. Now I'm going to say plus 2 times the area of the base. So now I'm going to say plus 2 times the area of the base. Now the base is a triangle, and the base of the triangle is height times base divided by 2. So look at this base. There's your right angle, and I said base and height is found by right angle, but we don't have the base or the height of that one. But if you look at the top, we do have those two numbers given to us up here. So to find the area of the triangle, we would say 9 times 12 divided by 2. So that would be the area of both of those bases. 9 times 12 divided by 2, and that's 54. So that is what goes into this formula. And all this should get you the answer that I've already provided for you. All right, so let's move along to our next example on this page. We're going to look at our soup can. All right, the previous page has our formula. I'm going to go ahead and copy that over so we don't have to keep flipping our pages. All right, so remember our base is the top and bottom of the can. So if hopefully you look at this picture and think that the can is laying on its side, okay? So we need two numbers. We need an R, and that's a radius for any circle, and a height of this thing. Since this is laying on its side, the height is not 15. The height would be the diameter of the base. I say the height, since this is sitting on its side, if we were to sit this can on its base, this can would be 9 meters tall. So our H would be 9 here. Now all we have to do is look at that circle and figure out what the radius is. The radius is half of the diameter, so it's half of 15 to be 7.5. And if you put all that in everywhere you see, so 2 times pi times 7.5 squared plus 2 times pi times 7.5 times 9, all that should get you this outcome. All right, so let's move on to the pyramid. So everybody's pretty familiar with what a pyramid looks like. Let's go to our previous page. Take our surface area formula. All right, so this says half of times L times P plus a capital B means area of the base. All right, our first time seeing L. L is a slanted height. Okay, so if you're on a pyramid, the height drops down the middle as if there was a hole that you jumped through the middle and you landed on the bottom. But a slanted height is more of sledding down a hill when it's snowing out. Okay, that's on its edge. That's a slanted height. So we're looking for a slanted height. And if you look at this dotted line here, where the 7.4 is, the slanted height shows you that it doesn't go through the middle, but it ends at the edge of the pyramid. So it hits right here on the edge of the pyramid. So our slanted height for L is 7.4. So our first number is 7.4 in this formula. Now perimeter is the perimeter of the base. Okay, the perimeter, the base that it's sitting on, it looks to be a square. So here's the square that it's sitting on, and it's 5 by 5. So that means it has 4 sides of 5. So we're going to say the perimeter is 20 because we have to add them. Now the capital B means the area of the base, and the area of the base that this is sitting on is a square, and that's side times side, which is 5 times 5, and there is your final number that goes into this formula. So all that, let me rewrite this 5, put in your calculator correctly, should get you your 99 inches squared for area of this pyramid. All right, so I went ahead and went to the next page in the packet, and I copied our formula once again right here for the pyramid. Now I want to show you the difference on this pyramid versus the one we just did, and recognizing the slanted height. L is the first one we need. Now the slanted height is not 3. The slanted height has to hit the edge. So if you do not have a slanted height, you would have to use this red triangle in here to create Pythagorean theorem and find the hypo, which would be the slanted height. So on this triangle, the slanted height is what we need, and that would be C in our Pythagorean theorem. A would be 3, so there's your A squared. The problem with the B part, this part right here, is that it's not 16. The entire side is 16. This line drops in the middle. So you would have to cut that in half, and the bottom of that number, or that triangle, would be 8. So after you use Pythagorean theorem to get your slanted height, then you would go about using your formula the exact same way on the previous problem to get our 528 feet squared for this pyramid. All right, here's our first cone. So we got pi r squared plus pi rl, which is slanted height. Now, hopefully you know this cone looks as if it's laying on its side, tipped over. So all you would need was be the radius of the square. The radius of the square here would be half of 27. So we would just say 27 divided by 2. And your slanted height, I'll use a cursive L, is given to us, 32.9. And then you just put these numbers in your formula where they appear, and your calculator will give you 1,967.89 millimeters squared approximately. Because we're using a pi button, it's not going to be perfect, but it's going to be rounded to 0.89 millimeters squared. All right, on number 9, I wanted to show you that you have a little bit of a work to do to get your radius here. So you do not have a radius. And what you should see here is that the radius is going to be a part of this right triangle. And therefore, you would have to use Pythagorean theorem again to find your radius. So this would be your setup on your right triangle to use a squared plus b squared equals c squared. And radius would probably be your b in your a, b, and c formula. And once you get your radius, then you would just put it in every time you see the r. But you already have your slanted height of 27.3. So that you already have, so you would just put it here at the end. And you will be ready to get your answer, which I provided. All right, so right here on when you have two pieces that you have to add together, so you have your cone on the top. So on your cone, you would need your L. There's your slanted height right there. You'd have your radius, which would be half of the 34. So on your cone on the top, you have what you need. And then for your cylinder on the bottom, your can, you would have your height, which is 12. And you would need your radius, which is 17. And then you would go to your formula sheet, get your surface area formula, put in your radius and height for cylinder, and then find your cone and put in your radius and slanted height into that formula. You'd get two numbers. You'd get this number for the cone, and you'd get another number for the cylinder, and then you would just add them together to get your overall surface area of this object.